Determine the values of the parameter S for which the system has a unique solution, and then describe the solution. So the first thing we want to do here with our given system is rewrite this system as a matrix equation. As matrix A times vector X equals vector B. So looking at our given system here, we have a 2 by 2 matrix S4 minus 6S negative 24S, and this is multiplied by a vector in R2, so x sub 1, x sub 2, which is all equal to the constant vector 3, 5. So we can see we have our matrix A multiplied by vector X equaling vector B. And so we can use this matrix A here to find the determinant. So the determinant of matrix A is equal to negative 24S squared minus a minus, so plus 24S. And we have a greatest common factor here of minus 24S multiplied by S minus 1. So here is our determinant, and we want to note or recall that a matrix A has a unique solution if and only if, or when, the determinant of said matrix does not equal 0. So to find where this system has a unique solution, we want to set our determinant not equal to 0 and solve for S. So I have minus 24 times S multiplied by S minus 1 cannot be equal to 0. And we have our two cases here. S cannot be equal to 0. And then S minus 1 cannot be equal to 0, which produces or shows us that S cannot be 1. So from here, we are able to conclude that our system has a unique solution for all parameters, or for all parameters S, except we should say for all real numbers S, except S equal to 0 and S equals 1. And we'll also box up our determinant of A here, because we are going to need that now to apply Cramer's rule to find the unique solution. So we are going to use our matrix A to find matrix A sub 1 of vector B and matrix A sub 2 of vector B and their corresponding determinants. So case 1 here, we want to find matrix A sub 1 of vector B, and we'll keep in mind that we find this matrix by replacing the first column of matrix A with vector B. So you can say matrix A sub 1 of vector B is equal to, so replacing this first column vector with B, we have 3, 5, and then the second column vector is still negative 6S minus 24S. And so the determinant of matrix A sub 1 of vector B is equal to 3 times minus 24, which gives us a negative 72S minus a minus 30, so plus 30S, which is equal to negative 42S. And now we want to go ahead and do the same thing to find, or a similar process to find matrix A sub 2 of vector B. And again, to find this matrix, we will replace the second column of matrix A with vector B. So we have matrix A sub 2 of vector B is equal to, so the first column vector remains the same, that's still S4, and the second column vector now becomes 3, 5. And so using that 2 by 2 definition, we see that the determinant of this matrix is equal to 5S minus 12. And so we are now ready to go ahead and find vector X, which again we'll keep in mind here is in R2. So we have the two components And we should keep in mind here that the determinant of matrix A, which we found at the beginning, was negative 24s multiplied by s minus 1, since we can't see it anymore. So a vector in R2 has two entries. So we have x sub 1. So by Cramer's rule, this is defined as the determinant of matrix A sub 1 of vector B, all divided by the determinant of matrix A. So we have in the numerator negative 42s, and in the denominator that's negative 24s divided by s minus 1, which simplifies to 7 all over s minus 1. And finding entry x sub 2, this is the determinant of matrix A sub 2 of vector B, all divided by the determinant of matrix A. So in our numerator, we have 5s minus 12, and that is all divided by negative 24s times s minus 1. And there is nothing to simplify there, so we are ready to state our final answer. So therefore, vector x in R2 is defined by the components. For x sub 1 is 7 by s minus 1. And then we have, for x sub 2, 5s minus 12. We can even put that negative in front. And this is all divided by 24s times s minus 1. And remember, this is such that our parameter cannot be equal to 0, nor can it be equal to 1. And so this is our beautiful final answer.